In this video, I'm going to go through the dot and cross diagrams for covalent molecules. I would recommend pausing here, doing these for yourself, and then pressing play when you're ready to go through the answers. Please just bear in mind that you will also going to have some double bonds and some triple bonds in some of these molecules, okay? To see if that's applicable, just look at the atoms that you've got in your molecule and see how many bonds they typically form. So for example, nitrogen, it's in group 5, it's always going to form 3 bonds, but it's only bonded to one other nitrogen atom, okay? So that means you're going to have 3 bonds between just 2 nitrogen atoms. You're going to have a triple bond, okay? Carbon, it's in group 4, it wants to form 4 bonds, but it's only bonding to 2 atoms. That means it's going to have a double bond to both oxygen atoms. So just bear that in mind, have a go of them yourself, and then come back when you're ready to go through the answers. I'm going to start with the first one, which is H2S. I'm always going to draw the atom that I've only got one of in the center. So I'm going to draw sulfur in the center, and I'm going to draw hydrogen on either side. Okay, H2S tells me I've got 2 hydrogens bonded to sulfur. In each bond, I must have 2 electrons. I've got 1 electron from sulfur, I've got 1 electron from hydrogen. The other bond, I've got 1 electron from sulfur, 1 electron from hydrogen. Okay, hydrogen only has 1 electron and I've drawn it. Okay, but sulfur is in group 6. It's got 6 electrons in total. I've only drawn 2 of them, which means it's got another 4 electrons that are not involved in bonding. Okay, when I add it up at the end, I've got sulfur with 2, 4, 6, 8 electrons, and I've got hydrogen with 2. Okay, hydrogen can only ever form 1 bond, so I know there's not going to be any double or triple bonds here. Sulfur, I did mention, can form more bonds than just 2, but in this case, it's only bonded to 2 atoms. It's only forming 2 single bonds. The next one, Hi, I've got a bond between hydrogen and iodine. Within that bond, there must be 2 electrons, 1 electron from hydrogen, 1 electron from iodine. Hydrogen only has 1 electron and I've drawn it. Iodine has 7. I've drawn 1 for iodine. I need to draw another 6. I fill them in, okay? And iodine has 2, 4, 6, 8 electrons. Hydrogen has 2. Again, hydrogen can only form 1 bond. It's only got 1 electron. That means it can only form 1 bond. So there's never going to be any double or triple bond between them, even though iodine could form more. If I do the next one, it's NCl3. Nitrogen's by itself, so I'm going to put it in the middle, and I'm going to put 3 chlorines around it. Okay. Nitrogen is bonded to 3 chlorines. Each bond contains 2 electrons, so I'm going to put nitrogen has 5 electrons because it's in group 5. I've only drawn 3 of them, which means I need to draw another 2 electrons for nitrogen that are not involved in the bonding. Chlorine has got 7 electrons. I've only drawn 1. That means for each chlorine atom, I need to draw another 6 electrons that are not involved in the bonding. When I do this, I will see that I've got chlorine. Each chlorine has got 2, 4, 6, 8 electrons, and I've got nitrogen with 2, 4, 6, 8 electrons, okay? I did mention that chlorine could form more bonds, okay? But nitrogen always forms 3. It's forming already 3 bonds with 3 different chlorine atoms. Nitrogen's not going to form any more bonds, therefore chlorine will also only form 1 bond. Chlorine can form more bonds, but it's totally happy just forming 1. The next example is BF3. Okay, I'm going to put boron in the center because I've got it by itself, and I'm going to put a fluorine on every side. Okay, that tells me I've got 3 bonds. In 3 bonds, I must have a pair of electrons, so I've got boron. Again, you can draw circles if you want, okay? Boron is in group 3. It's only got 3 electrons, and I've drawn them all. Fluorine's in group 7. I've only drawn 1 electron for each fluorine, so I've got another 6 electrons to put around each fluorine atom. When I do this, you will see that fluorine ends up with 8 electrons, so a full outer shell, but you'll see that boron only ends up with 2, 4, 6, okay? Boron is in period 2. A full outer shell would be 8 electrons. It's only got 6, okay? But the reason that boron can't form any more bonds is because it doesn't have any more electrons. It's only got 3 outer shell electrons, therefore it can only form 3 bonds, and boron just has to be happy with 6 electrons in its outer shell instead of 8. Fluorine is Also in period 2, 8 electrons makes a full outer shell, so fluorine is always going to form one bond, and it's happy with that. The next one we have got is F2O. So I'm going to put oxygen in the center, and I'm going to put a fluorine on either side. Between the fluorine and the oxygen, I've got a bond. I'm going to represent that by drawing 2 electrons. Okay, oxygen has 6 electrons in total. I've only drawn 2 of them, which means it's got another 4 electrons that are not involved in the bonding. Fluorine has got 7 electrons. I'd only drawn 1, so it's got another 6 electrons that are not involved in the bonding. Again, how did I know that there were no double bonds in between? Okay, oxygen's in group 6. It wants to gain 2 electrons, so it wants to form 2 bonds in total. Oxygen is bonding to 2 atoms already, so it can form 2 bonds by forming 2 single bonds, 1 to each fluorine atom. It doesn't form a double bond, okay? It wants 2 bonds in total, and it's got those 2 bonds by forming 2 separate single bonds. Fluorine only wants to make 1 bond, okay? It's only 1 electron shy of a full outer shell. It's only going to make 1 bond, okay? So that's what F2O is going to look like. If I then have a look at CS2, okay, carbon's in group 4. Sulfur is in group 6. So if carbon is in group 4, I know it wants to form 4 bonds, and it'll form 4 bonds every single time. It wants to form 4 bonds, yet it's only bonding to 2 different atoms. That means it must be forming 2 double bonds. Okay, it's going to form a double bond with each sulfur. That gives it its 4 bonds overall. I've got sulfur, which is in group 6. Okay, if it's in group 6, it wants to gain another 2 electrons. It wants to form another 2 bonds. So sulfur is also happy to form another 2 bonds. So sulfur is going to form a double bond with carbon. Okay, carbon only has 4 electrons, and I've drawn those 4 crosses already, but sulfur has 6. 2 I've drawn, but another 4 that I haven't drawn on each sulfur. So sulfur ends up with 2, 4, 6, 8, 2, 4, 6, 8, and carbon ends up with 2, 4, 6, 8. Okay, remember for carbon, 8 electrons is a full outer shell. Sulfur could form more bonds, but in this case, it's happy with 2. Okay, it can't form any more bonds than that to carbon because carbon can only have a maximum of 4. A similar example, CO2. Okay. Again, I'm putting carbon in the middle, I'm putting oxygen on either side. Carbon wants 4 bonds, it only has 2 atoms, therefore it must form double bonds with both atoms. Oxygen's in group 6, it wants to form 2 bonds, okay? It can form the double bond to carbon, and that's oxygen forming 2 bonds. Carbon's got 6 electrons, I've only drawn 2, so I've got another 4 to draw for each oxygen atom, and all atoms end up with 8 electrons in their outer shell, which is a full outer shell. The next one up is N2. I've got 2 nitrogen atoms bonded to each other. So nitrogen's in group 5 and it wants to form 3 bonds. Okay, if it wants to form 3 bonds and it's only bonding to 1 other atom, it must be forming a triple bond. So each nitrogen is contributing 3 electrons to the same bond, and you end up with a triple bond between the nitrogen atoms. Okay, nitrogen's got 5 electrons in total. It has 3 bonding electrons, but it's got 2 electrons left. This nitrogen also has 3 in the bond, and it's got 2 to itself. So I'm drawing 5 crosses and 5 dots to represent the 5 outer shell electrons of nitrogen. Because each nitrogen wants to form 3 bonds, I'm forming a triple bond between the 2 nitrogen atoms. The next example, HCN. So you've only got 1 of each atom, so I'm just going to draw them out in a line, H, C, and N. Okay? We know that hydrogen can only form 1 bond. Okay? It's only got 1 electron, it means it can only form 1 bond. So I'm going to draw hydrogen's electron here. It's forming a bond with carbon. Okay? If hydrogen is only contributing 1 electron, that means carbon's only going to be contributing 1 electron. Okay, there's forming 1 bond between hydrogen and carbon because hydrogen cannot form any more. But we know that carbon in total wants to form 4 bonds. Okay, it's formed 1 with hydrogen, but now it must form another 3 with nitrogen. So carbon's other 3 electrons are all going to form bonds with nitrogen. This suits nitrogen because nitrogen wants to form 3 bonds. Okay, nitrogen's in group 5, it wants to form 3 bonds, so it's happy to form a triple bond with carbon. Keep its other 2 electrons to itself. Okay, so if we look at the way I've drawn it, hydrogen can only form one bond. It's formed one bond. Carbon wants to form 4. It's formed 1, 2, 3, 4. Nitrogen wants to form 3. It's forming 1, 2, 3. I've drawn 1 electron for hydrogen, I've drawn 1, 2, 3, 4 electrons for carbon, and I've drawn 1, 2, 3, 4, 5 electrons for nitrogen. So I have the correct number of electrons drawn for each atom. I've got each atom forming the correct number of bonds, and I've got hydrogen with a full outer shell, carbon with 2, 4, 6, 8 a full outer shell, and nitrogen with 2, 4, 6, 8 a full outer shell. The next one was C2H4, okay? In this one, the 2 carbons are bonded to each other, and then you've got 2 hydrogens bonding to each of the carbons, okay? You would need to know the structure for that. Carbon, we said, wants to form 4 bonds, but it's only bonded to 1, 2, 3. So if I'm looking at this carbon, I know it wants to form 4 bonds, but it's only bonded to 1, 2, 3 atoms. That means I need a double bond someplace. I know hydrogen can only form 1 bond, so I cannot form a double bond between carbon and either of the hydrogens. Therefore, the double bond must form between the 2 carbons. So I'm going to draw 2 electrons here, and then I'm going to draw 1 electron here and 1 electron here. This hydrogen will contribute 1 electron, this hydrogen will contribute 1 electron, and the same is going to happen on the other side. So I'm going to use open dots for this carbon, and then I'll use other dots for this hydrogen. Okay, so each carbon is forming 1, 2, 3, 4 bonds, a double bond between the 2 carbon atoms, and a single bond with the 2 hydrogens. Hydrogen can only form 1 bond, so you cannot have a double bond between the carbon and the hydrogen. The next example, I'm just going to move back up here first, is H2CO. Okay, carbon is going to be in the center. I've got an oxygen and I have got 2 hydrogens. So carbon's in the center with 2 hydrogens and an oxygen around it. Okay, carbon wants to form 4 bonds. You've only got 1, 2, 3 atoms. I know I can't form a double bond between carbon and hydrogen. That must mean the double bond forms between carbon and oxygen. So I'm going to put 2 electrons there for carbon, 1 between each hydrogen. Hydrogen's only ever going to be contributing 1 electron to the bond. That's all it's got. Oxygen, I know, wants to form 2 bonds, so it's totally happy to form that double bond with carbon. Okay, oxygen's got 6 electrons in total. I've only drawn 2. The other 4 stay on oxygen as a lone pair. The next one I've got is PF5. Okay, phosphorus is in group 3, but in this case it's forming 5 bonds. Okay, I said because phosphorus is in period 3, it's in group 5. Because it's in period 3, it can form more than just 3 bonds. In this case, it forms 5. It's going to form 5 single bonds. Okay, so that's phosphorus is 1, 2, 3, 4, 5 electrons, all accounted for. In each case, fluorine, I've only drawn 1 electron, so you would need to fill another 6 electrons around each fluorine atom. How did I know that these were all single bonds? Well, again, fluorine can only form 1 bond, so I know they're going to be single bonds. And phosphorus, yes, it can form more bonds, but it's only got 5 electrons in its outer shell. The maximum number of bonds it can form is 5. It's bonded to 5 atoms, therefore they are going to be 5 single bonds. You're not going to have any double bonds. If I look at the next one, which is ClF3, okay, chlorine is in the center and it's forming 3 single bonds with fluorine. Again, how did I know that they were single bonds? Because fluorine can only form 1 bond, therefore they must all be single bonds. Chlorine is using 3 of its electrons in bonding. It's got 7 in total, so it's going to have another 4 electrons as lone pairs. Each fluorine is going to have another 6 crosses around it to make up all of fluorine's electrons. If I look at SO2, okay, I'm going to put sulfur in the middle and oxygen on either side. I know oxygen needs to form 2 bonds, and this oxygen atom is only bonded to 1 sulfur. So this oxygen is going to want to form a double bond with that sulfur. This oxygen is also going to do the same. There are 2 electrons involved in bonding, but each oxygen will have 4 electrons not involved in bonding. Then I've got sulfur that also has 6 electrons. 4 of them are involved in bonding. The other 2 are not. Okay, this video is about to go over 15 minutes, so I am going to pause it, or I won't be able to upload it, and I'll go through the rest of the answers at the start of the next video.